All right. First thing we're going to do is I'm going to read over. Um, First of all, I'm going to erase this so it doesn't confuse you. Okay. So the first thing I want you to do is we're going to this. You're going to write this into your notes, your little cheat sheet I gave you today. Okay. The correlation coefficient. Okay. So the correlation coefficient. This is what you'll write down, is the indicator of both strength and direction of a linear relationship. Okay. Strength and direction of linear relationship determines the correlation between the variables. This tells you how the variables are related. Okay. Whether one has effect on the other one, or seems to have a correlation with it. Okay. So that's the very first thing. Write that piece down. Now, if you remember, or if you look back a page, you'll see that there's an R equals underneath strong, moderate, and weak. This is what we're going to write down. Okay. So a strong correlation will have an R value greater than 0.7. Okay. I'll just write this. The R value will be between 0.7 and 1, and negative 0.7 and 1. So that's for a strong correlation. Now through this video, you have to pause it, write it down, pause it, write it down. Okay. A moderate correlation has an R value equal to 0.4 and 6, and negative 0.4 and negative 6. That should be negative up there. I just realized that. A weak correlation is between 0.3 and 0, but it can't be 0, okay? So like as close to 0 as possible, or negative 0.3 to 0, but it can't be 0, okay? Because why can't it be 0? Because no correlation, the R equals 0. Okay, so those are your three items there. Strong correlation, 0.7 to 1, or negative 0.7 to negative 1. So I want you to go back in your page. Make sure you have correlation coefficient written down, the definition, and then what the strength of each of those are. So hopefully you paused it there. Now what this is telling me, if you remember from this morning, or I guess not for you this morning, is when we have a whole bunch of dots or a whole bunch of data is really close to our line of best fit, right? It's going to have a strong correlation, so it's going to correlate with that. A moderate one will have dots still in the same direction, but all the way around. Then a weak, same, still going up, but much more spread apart. And then no correlation will just be random dots. Have no correlation at all. So that's number one. Number two that we're looking at here is a coefficient of determination. Okay. So correlation of coefficient does not determine direction, because the correlation coefficient, the one above, the R value, will be positive or negative whether it's going up or down. But it gives a relative strength between the two variables. Okay. The higher the R value, so R squared value, so the R squared values goes between 0 and 1. Okay. So low strength, the R squared value is going to be near 0. Okay. Strong, R squared is going to be near 1. Okay. So if you ever have an R value, let's say my R value is 0.5, I can find my R squared value by just taking my R value and squaring it. Okay. I'm trying if there's anything else there to work through. All right, and then I'll show you in a couple seconds how to use Desmos to figure this out. Okay, so that's an example of what we're working with here. So make sure your notes filled out, and we'll go from there. All right, so Desmos. So the way we find those values is we're going to use technology, in this case Desmos. And you can just go Desmos on your calculator. And just when you get there, just tap on the graphing calculator button. So first thing you can do is plug in your values. Okay. Then how you use the Desmos is you're going to type in this formula. Now this is the formula for linear regression. Okay. There's a spot in your note package that has linear regressions and your regression formulas. This is what you're going to write in there. So it's y1 squiggly line. Now the 1 refers to, see how it says a 1 up here? That data range. Sometimes it might not work, and if you have a y2 up here, up top, that's y. The linear equation yx1 plus b. And that gives us our r value here and our r squared value. Okay, so you can look here, it's telling you r value is equal to 0.55 or 0.56 approximately. So that's a moderate, which kind of makes sense because they're on their way up, right? The r squared value, so the strength of it, 0.3. Not too bad, right? But not that strong, okay? Now, if I were to plug in some different information here, and you're going to have to boringly watch me plug in information. Let's go, I go like 0, 0, oops, 0, 0, 1, 1, 2, 3, 4, 6, 5, 12, 6, 25. What happened to that number? Where's that 0? Oh, 0, 6. Oops. It should be 0, 0. Right? So here, we're not working with a linear regression. That we're dealing with line here. Generally, lines have the same space between these ones. We're working with a curve, so we're going to type in this equation. y1, a friendly little squiggly line there. Get rid of that exclamation mark. mx1, oh sorry, not mx1, ax1 squared plus bx plus c. Oops, I forgot the 1 right there, bx1. Okay, so then it takes the points there, my points, and tries to make it into a parabola. So it gives you an rx squared value, but no r value. That's because r's are only for linear. The r value is only for linear. All right. The last thing to add in there, I know this is super rushed. You're gonna have to pause, go back, pause, go back. Probably come in early tomorrow if you want to review. If you want to, if I ask you for the formula, all you do is you take this this m value and this b value and plug them in for these where the variable is. So in this case, the formula up here would be y equals, we take this number, plug it in, so make it 3.6x plus negative 2.9. On the bottom here, if you do this, it would be the A values going in. The A value goes in for the A, the B goes in for the B, the C goes in for the C. Okay, hopefully that helps you out, and I'll see you tomorrow.